So who am I? My name is Peter Berger. I'm a software developer. I've been developing consumer applications for about 20 years. I'm definitely a functional programming interested amateur. I wouldn't characterize myself as either an academic or an expert. I'm someone who took a run at Haskell a number of times, bounced off painfully a few times, and then eventually figured some things out. A few times a year, I volunteer at local schools, typically what we in America call middle school, which is from ages around 10 through 14. I talk to the kids about computers in general, but also programming specifically. And I run workshops teaching some simple programming and projects. And I usually start with this slide. I like this slide, this image, because one, it's kind of funny, but two, it also gets across the idea that making mistakes is a programmer's natural state. It's how we learn. That said, I might stop using this slide, and I'm going to talk about why a little later, and it'll be back. I was reading old computer papers, as one does, and I found this paper by Edgar Dijkstra, How Do We Tell Truths That Might Hurt? It's a humorous paper. I don't think it was intended as a serious contribution, but it's presented as a series of humorous aphorisms, and this was the one that really jumped out at me. In case you can't read it, I'll read it. It is practically impossible to teach good programming to students that have had a prior exposure to BASIC. As potential programmers, they are mentally mutilated beyond hope of recognition. I apologize for the overscan. Well, when I read this, I thought to myself, well, I learned how to program learning BASIC, so am I ruined? I'd like to quick show of hands. How many of people here, your first programming language was an imperative language? Okay, I'm going to jump right to the final slide. You're not ruined. That's it, talk over. Now, if this is just about Dijkstra, I would not have made an issue of it. He was making a joke. In fact, his very next aphorism, he took a shot at APL, called it a mistake carried out to perfection. So it's not really Dijkstra's paper that's the problem. The problem is this idea. The meme has kind of gotten hold in people's minds, and something I see echoed quite often. If you can't read all these, I'm not going to read them all. You can go online and find similar sentiments expressed nearly every day. People that don't have the baggage of the imperative style are a lot quicker to learn functional code. It might be easier to learn functional programming before the mind gets corrupted with imperative or object-oriented programming. So this is like the best way possible to trigger imposter syndrome. Nearly every person in this room, these statements are about, right? This one is my favorite. Studies have shown that if one learns a functional programming language first, it is much easier to learn imperative languages. So I read this and I thought, great, data, science, let's go read the studies. Now, it's possible I didn't find the precise studies being referred to here. The studies I found where people taught functional programming to freshmen or to high school students, they're a mixed bag. They present the sort of thing that you would expect to see. We taught functional programming, it went well, it didn't go that well. It's not a life-changing experience as a first language. In particular, I want to call out John Hughes's paper from his experiences teaching functional programming at Chalmers. It's probably one of the larger initiatives. When he began this effort, there was already a functional programming class at Chalmers. It was the first language, and it had been taught so poorly that an I Hate ML club had formed at Chalmers. And now hopefully with his efforts that doesn't happen anymore. But I think it's not so clear that if you teach functional programming first, everything is roses. So maybe it's true, maybe it's not true, but it's certainly not proven true. I would submit that this is an urban legend. It's a story we tell ourselves because we like how it makes us feel. So I care about it because I'm engaging with kids, as I said, once a year. Typically I'll do 1 or 2 day workshops where we try and make some concrete artifact together. And I teach this class in a lot of different programming languages. And if I pick the wrong one, I don't want to ruin them. That's why I care about it. We've used all of these languages at various times. Sometimes, if we're dealing with people who don't have access to computers or kids who really don't have the patience to sit down and program, we'll run exercises. My favorite one was with a class of elementary school students. We introduced the classic game Rocky's Boots. And then we played a game where we talked about binary circuits, and we said, you're an AND gate, you're an OR gate, you're going to sense for crosses, you're going to sense for circles, and we built circuits out of human chains. I really encourage doing this activity at work, regardless of whether you're children or not. It's a lot of fun. For older kids, I generally like to focus on a game because a game is a very concrete implementation, and the victory conditions are just extremely clear. Classic off by one error there. This is a game, a space battle game written in Lua and Love 2D. Which is a framework. We ran 2 classes simultaneously. These are human controlled. The second class took the first class's project and then implemented an AI for the red player, which is really good, really, I thought, a great enhancement. So I was curious about, could I use Haskell to teach this class? Because I'm interested in Haskell, and I wanted to see how it would go. So I ran some small trials first. I took 2 particularly advanced students, and we kind of went through the first 10 of the 99 prologue problems. It didn't go so well. I got to tell you, at age 12, they were not amused by this. I then took some of Joachim Breitner's materials from his CIS 194 class at University of Pennsylvania and built Sokoban in CodeWorld, and that went a lot better. So that told me, yes, a game is the way to go for this. So our final, the kind of real group was about 10 students who collaboratively designed and implemented Hangman. And when I say collaboratively designed and implemented, we spend the morning talking about what a function is, what it means to compose a function. We spend the late morning doing it on a whiteboard. No actual, we play a game of Hangman in person and talk about how we could break that down. And then the afternoon is spent actually implementing it. After this exercise was done, I did something I haven't done for the other classes, which is I asked some questions. And the first question was just, what do you like about Haskell? Did I walk out of range here? So many students talked about how it was different, right? I think Dario here was trying to be very nice to me. He was trying to find something to say, and he couldn't help himself and referred to it as annoying in the middle of the sentence. But he did say it was a nice change of pace. Samantha talked about how cool it was that you could do a lot with just a little bit, just a few lines of code. This was something that the kids with more programming experience called out, that Haskell's famous concision was more evident to them. The kids with less experience, I don't think, really twigged to this. I like how you can define a variable and just start using it without declaring it first, and naming parts of your code. What both these students are talking about from context is the where syntax. The first time we actually referred to a variable like in an expression, and then 3 lines later said where that variable that I referred to back there is this. That kind of blew their minds. They really liked it. It's not all good news. So this one I'm going to spend a little bit of time on. No, sorry, it's not this one. But this was from the first trial I ran with the list problems. This was this student basically begging me to show them any way to do things other than the way Haskell wanted him to do it. He didn't want to do recursion. He didn't want to do pattern matching. So this was really my clue that having 14-year-olds do the 99 prologue problems is a really stupid idea. You would think I would have figured that out earlier. This one is the one I'm going to spend some time on. I guess it's just not exactly how you would tell a friend how to do something. This is not meant as a joke, and I don't think Callie was joking. This is a desire for intuition. What Callie is saying is functional programming is not intuitive to her. And when she said this, every kid in the class nodded. And I don't think they were just playing along. These students approach programming in a very straightforward manner. The computer is a friend, and the challenge of programming is to find the words to tell the friend how to do something. And this, more than anything else, is what frustrates me when we talk about, well, if only we can teach people functional programming first. Inductive thinking, imperative thinking, is not something we do as programming or just as programming. It's how we live our lives, right? Someone last night at dinner was saying, first you go to the cabinet, then you get the can of soup, then you put the soup in the pan, then you heat it up, then you eat it. That's how we think. So when we are asking people to learn how to program functionally, what we're doing is we're asking them to learn a new way of decomposing problems. That's very powerful, and there are good reasons to do it. It is not obvious, it is not intuitive, and we shouldn't treat it, it's not a small step, and we shouldn't treat it like a small step. The loops are different from most of the languages I know. When David talks about loops here, he's talking about recursion, explicit recursion. We taught the students about map. None of them liked it. This was an actual comment made in the group chat. People really love for loops. For loops are like mankind's best friend. I almost want to say that the first functional language to truly break through to the mainstream is the one that renames fmap to for each. I think you should all think about that. Some related complaints. I don't like the syntax, all the funky little carets and stuff, like the backtick. I didn't like where you had to put the parentheses. Both of these students are talking about the same thing. They're actually talking here about how functions, in Haskell at least, can sometimes be prefix and sometimes be infix, and then you could add backticks, and whatever it was, it's now different. This really bothered them. If the rule was just, yeah, it's always prefix or it's always infix, they would have been happier. But that's what they're complaining about here. I also asked this question. So I made a chart to explain, to visualize the results, and it just looked too mean. 100% of the students preferred Python. It was a fairly small sample, so maybe that'll change. But there are. I know this. I want to make clear that what I'm not doing here is slagging off the language, because I think there were some interesting results. So first of all, no one in the game making class described Haskell as hard. The first two students who were doing the kind of more abstract stuff, they described Haskell as hard. When we were making Hangman, we broke that problem down. I want to make clear also, I go into these sessions with an idea of what I think the right kind of decomposition is. In the Hangman game, I told them what I thought they should do. They blew it away. They said, no, we're going to do it this way. And we followed that along, and they did that in a language that they had never seen before. So it wasn't hard. They did describe it as weird, which I think is fair. The fact that the earlier group described it as hard and the latter group did not leads me to the conclusion that what's actually hard is abstraction. Most of you in this room are probably professional programmers. You have some amount of experience. This ties into the question that was asked this morning of when is this stuff going to make sense? If you have written if you've written, I think the example this morning was a sorting function. If you've written sort on int and sort on floats and sort on characters, and you've done this so many times, the need for an abstraction becomes apparent. In other words, you understand what's the problem the abstraction is solving. That's the motivation to really understand it. I think without that motivation, it's just meaningless, right? So the first piece of advice I have for you if you're teaching kids, or spoiler, I think teaching anyone new to a language, start with the very concrete. I'm going to spend a little more time on this, even though it's not in my budget here of time. The abstraction, for those of us who are experienced, that's the fun stuff, right? I think particularly in functional programming tutorials, This is a problem. We think the abstraction is fun, so if I'm trying to learn about a new language and I go Google it, like the first 10 hits are all the most abstract stuff possible because we think that's interesting. Might want to rethink that. It suggests that we need better ways to onboard people into these languages. And I say these languages because I don't think that's just Haskell. The second point, I can't overstate the importance of tools. And I've boiled this down into the point, be focused. Be focused. Here is a partial list of things that I was not interested in teaching my classes. I did not want to teach them how to install or use a text editor. I did not want to teach them how to find files or manage a directory tree, possibly on a computer they don't have any permissions or access to. I really didn't want to teach them how to use a command line compiler, or how to manage the mental state of switching back and forth between an editor and a compiler. So you can see where I'm going with this. You're going to a web-based UI. This is Khan Academy's excellent JavaScript UI. It's implemented in, I believe, processing.js, or it was the last time I looked. That's what I used when I teach my JavaScript classes. So what are we going to do when we get to Haskell? I tried and chose not to use, although it's not any insult, a number of solutions here. There is an IDE for Mac called Haskell for Mac. It's very nice. Unfortunately, I can't make that platform assumption that everyone has a Mac. This is CodeWorld.info, which is a very Khan Academy-like. It has kind of native access to a really nice graphical library, so it's kind of well-suited for games. This is the one I probably would have used had I had no other constraints. But I did have one other constraint, which is I didn't want to have to sit and have 10 people write 10 separate programs. I wanted them to be able to collaborate. So that led me to Replit, which by a happy coincidence was beta testing they call it multiplayer support. And so we had 10 middle schoolers in this document all at once, spending about 5 minutes typing curse words at each other, if I'm honest, but then they got over it. And this allowed us to basically break the tasks down by function. We could say, Callie, you're going to do this. Dario, you're going to do that. And they could work kind of in parallel. Few minor bumps in the road. There were a few times when some students had to reload their web browser to get it to resync. But by and large, it worked really well. And you could see this program here. I'm not going to go into detail about it. I'm not going to run it. You can take my word for it. It's the Hangman program you've all seen. And I just want to point out that it's got some nice features, right? We're using algebraic data types. But what don't you see? You don't see polymorphism. Is that for me? So apart from the UI, apart from kind of the editing issue, what did we kind of run into? I would call out 3 major issues. The error messages, at least for this group, were pretty bad. I'm going to give an example of that. There were syntactical challenges around function application that I should have anticipated and did not, and I'll suggest some ways to avoid them if you're doing this. And it can be hard to grasp that type signatures and values live in different worlds. And that's made worse for anyone who's searching for sample code on the internet for a very specific reason. So error messages. This is feeding a string into a function that takes a character. Brutal honesty time. Who here has trouble reading this or interpreting it? A few people. OK. I have trouble reading this, and I know what it says, right? So right off the bat, you have to know that bracket char is a string. You have to know that this and this are the same thing, but for some reason, the compiler is giving them to you with different names. You have to know that these 7 sentences, which are trying, or 7 lines, which are trying to be helpful. I mean, let's be clear. This is trying to tell you where your problem is. There's a lot of squinting you have to do to kind of dechaff it. Here's the same error, or roughly the same error, in Elm. I find that a lot easier to read. I think there are reasons why Haskell describes this, and I think that, or Haskell error messages look like this, and they're good reasons. I would suggest if you want to contribute to the Haskell community, working on making this look more like this when possible would be a great contribution.
I second that.
You, he likes me, he really likes me. All right. I'm close to running over, and I still have some important stuff to talk about. I'm going to go very fast through this. Function application. Don't use long chains of composition when introducing Haskell to new programmers. Use lots of parentheses. They're free. This is what I was talking about. Namespace. These A's, totally different A's. These A's, totally different A's. It's fine. Do this, like use longer names. The Haskell police are not going to arrest you if you name a variable something other than X and Y. I don't know what to say for this slide. This is something that every student did. I have absolutely no explanation for what they expected to happen or why they did it. I haven't seen it in any other language. So you're not going to ruin a mind by teaching them the wrong programming language. It takes a lot to ruin a mind. It takes less to convince someone that they're not wanted. So we can do this in both unconscious and conscious ways. I want to go back to that image I used of our mega cool Atari programmers at the beginning of this talk and why I'm probably not going to use it anymore. This is the cover to Atari Basic, 1983. I don't want to make too much of it, right? I mean, it's a marketing picture used to sell a game about programming, right? A programming game. But let's do it anyway. Who are these dudes? Well, they're dudes, right? They're white. One has a magnificent 1970s mustache. They're using both hands. They're concentrating. They are clearly operating a spaceship. That's Jupiter, right? I think. So this sends a message. It sends a message not just about what programming is, but about who programmers are. And you know, people hear that message. People pay attention to that message. This depressing chart is from the Planet Money podcast. It describes the participation of women in medical school, law school, the physical sciences, and computer science. Go rocketing straight up through the 1970s, and then computer science goes all the way down. So one conclusion we can draw is that computer science is somehow special, and there's a good explanation for that. My conclusion is that there's a terrible explanation for that, and we have to be aware of it. I hesitate to talk about this in too much detail. It's very easy as a privileged person for me to say, you know, not my problem. But I want to submit to everyone in this room, it is your problem. The way I've become a better programmer, I can't speak for everyone, but the way I've become a better programmer is by talking to people who are as smart as me or smarter, or who just have a different perspective, or have done things that I haven't done, have had experiences that I have. That's everything I've learned. That's how I've learned it. So when I look at this gap, what I see is a bunch of women who were kept out of our career, whom I could have learned from. So if you're looking for a selfish reason to care about this and want to make it better, that's your selfish reason. And I also want to make clear, this chart focuses on women because this was the best visualization I could find. I am positive, 1 minute, I am positive I could draw a chart like this for every other underrepresented group. So what do? I'm running out of time. I'll refer you to Google's report, Unconscious Bias in the Classroom, Evidence and Opportunities. Nurture the motivation to reduce unconscious bias, build awareness of it without blaming or shaming, and reduce anxiety through increased contact. But there's another type of bias. And here I want to tell you about Laura. Laura was a girl in one of my classes whom I was teaching. I believe it was the Lua class. And I iterated a bunch of programming languages in what I was saying. I said, you might see this in Java or C or C#. And Laura just kind of quietly said, or HTML. And I just kept going, and then 5 minutes later I said, yeah, you might do this in Python or JavaScript. And Laura said, or HTML. And I stopped, and she said, HTML is programming. And I agreed, but in my heart of hearts, I don't know that I believed her. I thought, yeah, it's kind of programming, right? So this is a game called Crosscode. It's written in HTML5 and Canvas 2D. It's fantastic. And Laura was right, and I was wrong. And without even, well, I mean, I shouldn't say without even telling you, I had a conscious bias. that HTML is not programming. And I gave her that message. And that's not really good enough. Laura was brave to bring that up. Your students, if they're young, especially if they're young, are generally not going to confront you about your biases. So you need to be, if you're teaching, you need to be extra aware of those biases. What other biases do we have? Knowing a specific programming language makes you smart. How many people have felt this bias? Knowing functional programming makes you smart. That's a bias. Knowing Haskell means you're smarter because it's hard. And we see this. We have data on this, right? This is the State of Haskell survey. Read the things people say. This is the people who are into the language enough to answer a survey. People make insecure jokes about it on Reddit every day. So my point is not don't make jokes, don't feel insecure, don't express yourself. My point is be aware that people who are looking up your language on the internet, like they're going to encounter that for the first time, and most normal people are going to say, maybe this isn't for me, maybe this is too hard, because it's not true. So be concrete first, be focused, decide what you want people to learn, and then teach just that. Be open to people who have been traditionally excluded, to bringing them on board, and be kind. No one wants to look bad in front of their peers. When someone makes a mistake, please, please assure them that every programmer makes mistakes, and mistakes, in fact, are how we learn. Final slide, I promise, other than my brilliant conclusion. Yes, kids can learn Haskell. I believe the community should improve its onboarding experience. I think this is not just Haskell. I think this is most functional programming languages. And I think Haskell's reputation is probably doing it some harm here. And in my opinion, as someone who's used the language for a few years now, I don't think that reputation has to be there. I think it's something that we are bringing on ourselves, and we should try harder not to. So no one's ruined. Thank you very much. And I want to call out especially the teacher who let me experiment on her class, the kids themselves, and the notes for this talk and the slides will be posted right there. Thank you very much.